Because it's happening at the level of the myofibril. Those actin and myosin head, when you generate force, that's where it's at. So when that inorganic phosphate leaves, and you have good contraction here, that inorganic phosphate leaves, really good tight now on there so that you can pull that actin with that myosin head, okay? Great videos, and you see them all kind of, it's like they're climbing ropes, okay? Think about it, what would happen if we were all doing it at the same time?
Take too long.
Would we even be able to do it? So you would, if they were all working at the same time, attach, pull, then what would happen when you detached? It would slide back to where it was. You wouldn't be able to do any contraction if they were all working at the same time, right? So now you get to see that they're all going like they're climbing ropes, okay? Because if we were all doing it like this, as soon as you released, there'd be no tension. It'd go back to where it was at. Futile, wouldn't be able to do it, okay? Now think about the complexity of that. Think about the number of steps that we just watched 3 videos that were exceptionally complex, each video, in order for you to initiate muscle contraction. You do it all the time. Not even thinking about it, right? Your body's functioning. Right now, what are you doing back there? Well, fidgeting. Yeah. Is that muscle contraction? You were writing. Did you think about everything that was going in there? Excitation, contraction, coupling. ATP going in there so that you could get contraction so that you could write. You don't appreciate your body when you're a beautiful machine. All you guys are. I'll never say that again in my life to you. So that was as good as it gets, huggy wise. So I'll put these videos up. You can go and look at the 3-dimensional and text versions of this. Does anybody know where my mouse is at? Okay? That are in the notes. So here is beautiful artistic drawing of the neuromuscular junction. Has the same steps. It's just not the same. Okay? You can go look at what's happening here with regards to the myofibrils. Okay? Here we are. Relationship with troponin, tropomyosin, and the myosin fibers with covering actin. Okay? And here is excitation, contraction, coupling. Those videos, you take this slide all the way to that slide, and we just watched all 3 of those videos, and they are so much better. So much easier for you guys to learn skeletal muscle contraction compared to that. Yeah, I know.
So in isometric contraction, is the one head is bound, like for ATP, so obviously if you bind ATP it's going to detach, so are you basically just switching those out in the same position?
Yep. So they're not just staying in there, because if you have ATP is going to bind and it's going to release, load, attach. It's just not going to be able to shorten.
Right.
So
but they're switching it out, they're just staying in the same spot.
That's exactly right. So the myosin heads are just, you don't get any of this. And you'll get the loading of it, but then it goes and they just can't, you're just not moving it.
And then like cramping, is that?
So what is cramping?
Would that be like you don't have ATP to release the muscle, or?
Mm-mm.
Lactic acid buildup.
So when does cramping take place usually? Electrolytes. So maybe what electrolytes are involved in muscle contraction?
Calcium?
Calcium could be one. What's another one?
Potassium, sodium.
Potassium, sodium, which are what? They're going to be responsible for generating those action potentials from the nerve to the skeletal muscle. So if you have deficits in your electrolytes, potentially you're going to have some issues with pH, first of all. Maybe fluid balance to begin with. Maybe you don't have enough fluid in this viscous environment, but potentially, if it's severe enough, you're going to affect how your physiology is working with regards to generation of action potentials. Okay? So we'll quit early a little bit because I got to go get this video done. I'll put these videos up shortly, and then we will continue on our journey. If you want to come and talk to me about